You're listening to DTF for February 27, 2026. I'm your architecturally suspect host, Jack Haxman. We are your daily tech feed for Hacker News, a website where people who build systems argue about whether systems should exist. Today's got that restless energy where everything to next if you squint hard enough. Let's get into it. I've spent enough time building systems to know that the most dangerous moment isn't when something breaks. It's when someone changes the requirements after deployment. Get designed for one threat model, optimized for one set of constraints, and then the person holding construct says, actually, we needed to do this other thing too. And that other thing is the thing you specifically architected against. That's what's happening in Anthropic right now. And the engineering of this situation deserves real attention. Dario Amodei published a statement this week about Anthropic's relationship with the Department of Defense. And he's calling it the Department of War, which is its original name. And that choice alone tells you something about the register of this conversation. The statement lays out two lines Anthropic will cross: mass domestic surveillance and fully autonomous weapons. Everything else, they're in. Claude is already deployed across classified networks, intelligence analysis, cyber operations, operational planning. This isn't hypothetical. It's production. Now, follow the logic to its endpoint. Amodei says the Defense Department has threatened to invoke the Defense Production Act if Anthropic maintains these two constraints. They've threatened to designate Anthropic a supply chain risk. That's not a negotiation. That's compulsion with legal machinery behind it. And here's where the engineering admiration kicks in, because the argument Amodei constructs is genuinely elegant. He doesn't say autonomous weapons are wrong. He says frontier AI systems aren't reliable enough to power them today. That's a falsifiable technical claim, not a moral stance. It has an expiration date built into it. The moment reliability crosses a threshold, the argument dissolves. He's buying time with an engineering constraint, and he knows it. The surveillance argument is stronger and more permanent. He points out that current law lets the government purchase detailed records of Americans' movements and web browsing without a warrant, simply because the law predates the capability. AI doesn't create new surveillance. It assembles scattered data into a comprehensive picture of any person's life, automatically and at massive scale. The architecture of the system determines whether it liberates or controls, and mass surveillance is a closed system by definition. It concentrates information asymmetrically. One entity sees everything. Everyone else sees nothing. The comments on this are doing real work. Several point out that Anthropic has walked back safety commitments before. Their head of safeguards research departed under unclear circumstances. The RSP updates loosened constraints. Trust is a version-controlled document, and the depth matters. What I find genuinely compelling is the open letter from employees at Google and OpenAI supporting Anthropic's position. That's cross-organizational solidarity on a principle, which is rare enough to notice. The real question isn't whether Anthropic holds these two lines. It's whether the legal framework exists to let any company hold any line when the Defense Production Act is on the table. That's a congressional problem, not a corporate one. And right now, Congress is asleep at the switch. Completely different energy now. From policy fights to pure technical curiosity. Pause. Can you reverse engineer a neural network? In 1997, a graduate student named Fabrice Bellard wrote a C program that computed pi to a world REH chord number of digits on a desktop PC. The interesting part wasn't the math. It was that he published the source. Anyone could read it, understand the algorithm, verify the result, improve on it. The computation was impressive. The legibility was revolutionary. Jane Street, one of the most secretive quantitative trading firms on the planet, did something structurally similar here. And the irony is worth sitting with. They hand-designed a neural network, published every weight, every bias, every layer, and said, figure out what it does. Not a black box. A glass box. Full specification. Zero documentation. The puzzle itself is genuinely beautiful engineering. The network outputs 0 for almost all inputs. You can't backpropagate your way to an answer because the gradient landscape is essentially flat. You have to actually read the architecture and reason about what computation it encodes. Alex, the university senior who cracked it, started where any good reverse engineer starts. The output layer then worked backward. He noticed the weights were all integers, not trained, hand-designed. Someone built this thing like a circuit, not like a statistical model. The second-to-last layer turned out to be computing byte-wise equality between two 16-byte integers, using ReLU activations as comparison gates. That's not machine learning. That's someone encoding a specific algorithm into the geometry of a neural network, the way you'd hide a message in the structure of a building. This is mechanistic interpretability as a puzzle, which is clever. But it's also mechanistic interpretability as recruiting tool, which is honest. Jane Street is telling you exactly what skill they value. They want people who can look at a trained model and understand what computation it's actually performing. Not what it was trained to do, but what it does. The gap between those two things is where the interesting problems live. One comment nailed the trajectory. Model interpretability is going to be the final frontier of software. You used to debug code. Now you debug the AI. The difference is that code was designed to be readable. Neural networks were not. The tools for reading them are being invented right now. In puzzles like this one, in research labs, in open papers. The puzzle was published with full weights. The solution walkthrough was published with full reasoning. That's the architecture that matters. When the knowledge is available, people build. When it isn't, they guess. Open knowledge builds better AI. Open governance builds better software. F-Droid is opening nominations for his 2026 Board of Directors. 4 volunteer positions, 2-year terms, 1 to 3 hours a week. That's what it costs to help govern the App Store that 60 million people use to sidestep Google's control over their own phone. F-Droid is taking nominations for its board of directors, and the requirements tell you everything about how this project thinks. You don't need to be a developer. You don't need board experience. You don't need a resume full of acronyms. You need to care about the freedom of people who use computers. Specifically, the ones they carry in their pockets. Run the math on mobile software distribution. There are exactly 2 gatekeepers for the vast majority of humans on Earth. Apple runs one store. Google runs the other. Both take a cut. Both enforce rules. Both can remove any application at any time for any reason. And your recourse is an appeal form that disappears into a queue. F-Droid exists because a few people decided that was architecturally unacceptable, and then built the alternative. The nomination process itself is worth noting. Meetings are open to the public. The statutes are published. Voting is weighted to favor new candidates over incumbents. A structural check against entrenchment baked into the governance layer. Compare that to how the two dominant app stores make decisions about what software you're permitted to install on hardware you purchased. One of the comments on the announcement asks whether F-Droid will survive Google's upcoming platform changes. The other commenter answers it. Maybe without realizing, you start open source at the kernel. Android runs Linux. The kernel bows to no one. F-Droid doesn't need Google's permission to exist. It needs maintainers, it needs infrastructure, and right now it needs 4 people willing to spend a few hours a week making governance decisions in the open. The deadline is March 16th. The email is boardnominations@f-droid.org. The current board has 7 members. Their names are public. Their meetings are public. Their process is public. That's the whole pitch. An app store that serves 100 million installs, governed by volunteers, funded by donations, accountable to its users, and actively recruiting the next people who will shape it. The door is open, the requirements are reasonable, the work is real. 4 stories, and we've gone from governance to graphics algorithms. I love this show. Let's talk about quadtrees. Let me make the case for brute force. You have 1,000,000 points. Modern hardware can crunch 1,000,000 distance calculations in milliseconds. Memory is cheap. CPUs are fast. And the simplest code is the code with the fewest bugs. Why will you add a tree structure with all its allocation overhead, its edge cases around boundaries? It's rebalancing logic when you could just scan the list and be done. The answer is that the question itself is wrong. It's not about whether your hardware can handle 1,000,000 comparisons. It's about what happens when the user scrolls. Every frame, every pan gesture, every pinch to zoom fires a new query. 1,000,000 comparisons 60 times a second is 60 million comparisons per second. On a phone, while rendering a map, while managing network requests, while trying not to drain the battery before lunch. Brute force doesn't fail on one query. It fails on the second one, and the third, and every one after that. A quad tree solves this by doing something deceptively simple. It divides a 2-dimensional plane into 4 quadrants. If a quadrant gets crowded, it subdivides again. Dense areas get fine resolution. Empty areas stay as single large cells. The structure adapts to the data rather than imposing a uniform grid. The elegance is in what you skip. When you search a quad tree, you walk down from the root, and at every node you ask one question: does this quadrant overlap my search area? If it doesn't, you ignore it and everything inside it. One comparison eliminates 1/4 of the remaining space, then 1/4 of what's left, then 1/4 again. You go from checking every point to checking almost none of them. This is binary search extended into 2 dimensions. Same principle, same logarithmic payoff, but applied to space instead of a sorted list. What makes this particular article worth your time is that it's interactive. You drag a search region and watch the brute force approach examine every point while the quad tree skips entire sections of the map. You click to place points and watch the tree subdivide in real time. You step through the insertion algorithm line by line. The data structure stops being abstract and becomes something you can see responding to your input. The author built the kind of teaching tool that makes a concept stick on the first encounter. No library, no framework dependency. Just clear thinking, rendered visible. The tools exist. The knowledge is available. Someone put it where you can reach it. Now that we've mapped data in 2 dimensions, Story 5 maps something far more elusive. The hunt for dark breakfast. Buried in the IHOP corporate website, In a document most people would never think to read, there's a detail about their omelets. They add pancake batter. That one line is the Rosetta Stone for this entire piece. Ryan Moulton did something genuinely delightful here. He took 3 ingredients that every culture on Earth has access to: milk, eggs, flour, and asked a mathematician's question about a cook's problem. If you plot the ratio of these 3 ingredients on a simplex, a triangle where each corner represents pure milk, pure eggs, or pure flour, every breakfast you've ever eaten maps to a specific point. Pancakes cluster in one region. Omelets hug the egg vertex. Baked goods spread across the flour-heavy side. But there's a region in the middle of that triangle. High milk, moderate egg, low flour, where almost nothing lives. He calls it dark breakfast. Breakfast that, the math says, should exist, but that no known cuisine has explored. The parallel that comes to mind is the periodic table in 1869. Mendeleev arranged the known elements by atomic weight and balance, and the gaps told him what was missing before anyone found gallium or germanium. The prediction preceded the discovery. Moulton is doing the same thing with batter ratios, and the fact that it's breakfast instead of chemistry doesn't make the method less sound. What I love about the craft here is the rigor beneath the comedy. He actually plotted the recipes. Kaiserschmarrn, Dan, Bing, blinis, clafoutis. Each one placed by its actual ingredient ratio. The map fills in and the void persists. The comments are doing real work too. Someone services Sri Lankan egg hoppers, which sit right at the edge of the abyss. Someone else recalls the omelette from a short-lived Manhattan restaurant that apparently ventured directly into the dark region and didn't survive. The data points keep arriving and the gap keeps holding. The piece works because it treats a kitchen as a search space and a mixing bowl as an experimental apparatus. That's not a metaphor. That's literally what cooking is. Parameter optimization over a continuous space, constrained by chemistry and tradition. Most of the space remains unexplored because recipes are inherited, not derived. Nobody walks into a kitchen and says, "What happens at 0.4 milk, 0.35 eggs, 0.25 flour?" Moulton did. And the answer is, we don't know yet. The dark breakfast is still out there, waiting for someone to pour it into a pan. What else lives in unexplored parameter space? How about the entire Windows 95 executable library, running in your browser tab? What does it take to run a Windows executable? Not on Windows, not on Linux with Wine, not inside a virtual machine, in a browser tab. The answer is, you have to rebuild the world. Every single layer of it. The x86 instruction set decoded and executed one opcode at a time in TypeScript. The PE loader that parses those portable executable headers, maps memory sections, resolves import tables. Then, the actual Win32 API surface. Kernels GDI Sarho. Hundreds of functions that Windows programs call expecting an operating system to be on the other end. RetroTick puts a web page on the other end. And somehow FreeCell deals cards. The technical constraint here is fascinating. An x86 CPU processes instructions through a pipeline that was refined over 4 decades of silicon evolution. Re-implementing that pipeline in a language that compiles to a JavaScript engine that runs on whatever CPU your machine actually has. That's at least 3 layers of abstraction that shouldn't work. The flag evaluation alone is a nightmare. x86 has this Byzantine system where arithmetic operations set condition flags that later branch instructions read, and if you evaluate those flags eagerly on every operation, your emulator crawls. RetroTick does lazy flag evaluation, computing them only when something actually checks. That's the kind of optimization that separates a proof of concept from something that runs ski-free at playable speed. But the part that matters isn't the CPU emulation, it's the API surface. Wine has been re-implementing Win32 for over 30 years, and is still not done. RetroTick ships enough of kernel 32, user 32, GDI 32, shell 32, and 24 other DLLs to boot real executables. They even mapped OpenGL 1.x immediate mode. The old GL begin go vertex scaling pipeline. Onto WebGL 2. That's how the 3D maze screensaver runs in your browser. Immediate mode to retained mode translation. In real time, in TypeScript. And the whole thing is CC0. Public domain. The README says the initial code base was generated entirely by AI, and they recommend contributing with Claude Code. There's something quietly profound about an AI-generated re-implementation of proprietary interfaces, released with no rights reserved, that lets anyone run software from an era when Microsoft controlled the entire stack. The executable format is documented. The API surface is documented. The instruction set is documented. All RetroTick did was take public knowledge and build the machine that was always implied by the documentation. The tools exist. The knowledge was always available. Someone finally assembled them in the one place everybody already had. A browser tab. Now a sharp turn. We've been celebrating what people build when knowledge is open. Story 7 asked what happens when institutions decide to close ranks. One commenter posted a link to a short video of Lee Kuan Yew describing a Singaporean customs officer who was offered a bribe and refused it, not because of some grand moral framework, because the system he worked in made refusal the default. The institution was designed so that corruption was the aberration, not the norm. That's the entry point into this 2-decade-old paper by Ashforth and Anand, and it lands harder now than it did in 2003. The core argument is deceptively simple. Corruption in organizations doesn't start with villains. It starts with normalization. 3 pillars. Institutionalization, where corrupt practices get embedded into routines and standard operating procedures. Rationalization, where people construct moral justifications. Everyone does it. It's for the good of the company. The rules are unreasonable anyway, and socialization, where newcomers learn that this is just how things work here. You don't even have to be coerced. You absorb it. The paper calls it the social cocoon. A worldview so internally consistent that participants genuinely don't experience what they're doing as wrong. Run this forward. Imagine an organization where the thank you gift after a favorable decision becomes routine, where the line between gratitude and incentive dissolves not through any single act, but through 1,000 small normalizations. The HN commenters pointed directly at the 2024 Supreme Court ruling that distinguished gratuities from bribes, essentially codifying the rationalization pillar into law. One commenter called it the mechanism by which the entire country falls. That's not hyperbole if you take the paper's framework seriously. When the highest institutional authority validates the rationalization, you've removed the last friction point. What makes this paper worth reading in 2025 is the architectural insight. Corruption isn't a bug in human nature that you fix with ethics training. The paper is almost dismissive of ethics courses. And the commenters noticed, pointing out the irony of mandatory compliance classes that exist primarily to provide legal cover. Corruption is a systems problem. The Singaporean example works not because Singaporeans are more virtuous, but because the system was designed with different defaults. This is an engineering problem. You can design institutions where transparency is the path of least resistance, where information flows openly, where the cocoon can't form because sunlight keeps reaching the interior. Or you can design institutions where opacity compounds and every layer of abstraction adds another place for normalization to take root. The blueprints for both architectures exist. The question, as always, is which one we choose to build. One project that's been choosing transparency by default for years now. PostmarketOS just hit another milestone. What does it actually take to keep a phone alive? Not the battery, the software, because every phone you've ever owned was designed to die. Not mechanically. The hardware is fine for a decade. But the software support window closes, the security patches stop, and suddenly you're holding a perfectly functional computer that nobody will maintain. PostmarketOS asks a different question. What if the kernel just worked? Not a custom kernel hacked together for one specific device. Not a vendor fork frozen in time, but a generic mainline kernel that runs across hardware the way Linux has always run on PCs. They now ship 3, mainline, stable, and LTS, their own builds, their own configuration, their own quality checks. The same kernel architecture that made Linux dominant on servers. Applied to the phone in your pocket, run that forward, a phone where the kernel updates independently of the manufacturer, where security patches arrive because you're running a real Linux distribution, not because Samsung or Google decided your model still deserves attention. That's not a feature. That's a completely different ownership model. And then there's the AI policy. PostmarketOS now explicitly bans generative AI contributions. No code, no documentation, no partial assists. The reaction splits predictably. One camp says they're Luddites killing their own velocity. The other says they're protecting code provenance and legal clarity. But the first principles question is simpler than either side makes it. Who is responsible for contributed code? In an open-source project, every patch has a human author who understands what it does, can defend it in review, and can maintain it later. Generative AI breaks that chain. You get code that passes review, but has no author who truly understands its internals. The project inherits maintenance debt from a contributor who can't explain their own contribution. For a project trying to keep phones alive for a decade, that trade-off is obvious. Long-term maintainability beats short-term velocity every time. They're optimizing for the right timescale. Meanwhile, the community keeps building. Bashan returns after years away, gets call audio working on the Fairphone 5. Clayton is building an immutable variant. They're setting up hardware CI, real infrastructure for real longevity. This is what it looks like when a project decides phones are computers and treats them accordingly. What happens when you take that same philosophy and apply it to the entire software stack? Story 9. Breaking free. I spent a week once debugging a recommendation system that kept servicing content nobody asked for. The fix was straightforward. A misaligned objective function. But the interesting part was how long it ran before anyone noticed. The system was optimized to maximize engagement. And engagement, it turns out, doesn't care whether the user is happy or horrified. It just needs them to keep scrolling. That memory came back reading the Norwegian Consumer Consul's latest report. The numbers are architectural. Meta estimates 10% of its own annual revenue, $16 billion, comes from fraudulent ads running on its platforms, not estimated by regulators, not alleged by prosecutors. Meta's own internal assessment, $16 billion in fraud, treated as a line item. Think of it like a canal system. You build the waterways, you control the locks. You collect tolls from every vessel that passes through. Now, imagine 10% of those vessels are running contraband, and you know it, and you keep collecting the tolls anyway. At some point, the canal operator isn't negligent. The canal operator is a participant. The Consumer Council's prescription is precise. Rebalance power between service providers and consumers. That language is clinical, and the clinical framing is the point. This isn't an emotional appeal. It's an engineering specification. The current architecture concentrates control over data, over attention, over the marketplace itself. Instructions designed to extract, not to serve. The counter-architecture already exists. Decentralized identity. User-controlled data stores. Advertising models where the person seeing the ad controls what data the advertiser can access. None of this is theoretical. The protocols are written. The reference implementations ship. What's missing is the regulatory will to make interoperability mandatory rather than optional. $16 billion buys a lot of inertia. But the Consumer Council is doing something specific and useful here. They're putting the vendor's own numbers into the public record. When the platform's own accounting confirms the scale of harm, the conversation shifts from whether to act to how fast. The tools exist. The question, as always, is who decides to use them. Tools that serve people instead of extracting from them. Let's talk about one being built right now, a Better Streams API for JavaScript. In UU 每这么度转的演需要着它的三次的纯生成门加大的 I/O. With the blocking streams, it worked, but it didn't scale. So, in 2002, they shaped Java.io with channels, buffers, selectors. A non-blocking architecture that was technically superior and almost universally despised. The ceremony was extraordinary. Reading a file required acquiring a channel, allocating a buffer, flipping the buffer, compacting the buffer, closing the channel. Developers wrote wrapper libraries just to avoid touching the API directly. It took until 2011 and Java.nio .aida to get something that was both powerful and humane. The WWDR stream standard is living through the same arc. James Snell, who has implemented these streams in both Node.js and Cloudflare workers, has laid out the case with precision. The API requires acquiring a reader, managing a lock, manually iterating a value-done protocol, and releasing the lock in a finally block, just to read data to completion. This is a ceremony that exists because the spec was finalized in 2016, 2 years before JavaScript got async iteration. The language caught up. The API didn't. The numbers are difficult to ignore. Snell's alternative, built on async generators and native JavaScript primitives, runs 2 to 120 times faster across every major runtime, not through optimization tricks, through elimination of abstraction layers that no longer need to exist. When your performance ceiling is set by spec-mandated indirection, no amount of engine tuning closes the gap. What matters here is the method. This isn't a competing proprietary framework. It's a demonstration, published on a company blog with benchmarks anyone can reproduce, arguing that a standard should evolve. The replacement primitives are async generators, async iterables, abort signal. Features already in the language, already understood, already optimized by every engine. The proposal is to build on what JavaScript already is, rather than maintain a parallel universe of streaming abstractions designed before the language was ready. The spec served its purpose. The language outgrew it. This has been your daily tech feed for Hacker News for February 27th, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voiced by QN3TTS. Not affiliated with Hacker News or Y Combinator. Now go build something that outlasts you. We'll see you back here tomorrow.